Okay, welcome back. Yesterday we talked about what a transformation was, and we looked at the first type, which is a translation. Today we're going to look at the second type, which is a reflection, coming from section 4.8 and 9.3 in your book. Reflections are transformations, that is a flip across the line of the pre-image. We're going to talk about coordinate notation for a reflection, and it is about the x-axis. xy goes to the point x negative y. On these ones right here, I think it's kind of easy to remember if we just think of a graph. We have our x-axis and we have our y-axis, and we have some point here, and then they want me to reflect it about the x-axis. So my point that was up on top of the x-axis has got to go the same distance down below the x-axis. That would be a flip. So if you think about it, the x value has to stay the same, but the y value will change. So the x stayed the same, but the y had to go to the opposite because it went below the line, which made it a negative. So the coordinate notation for an xy says I'm going to keep the x the same but change the y. About the y-axis, it says here's my red point, and I'm going to go to across the y-axis right here, so the point's going to move here. So this time the x value is going to change from a positive to a negative, and the y value is going to stay the same. So the x changed, but the y stayed the same this time. I believe you worked with those a lot, that I think most of you will be pretty good with reflections, but since we're in high school now, we're going to take it up a couple notches. The first one we're going to look about is about the line y equals x. So if you think of a graph, just a normal graph, the line y equals x is this line right down the middle here. That's my line y equals x. So my points have to flip. Now notice what happened. They exactly flipped. If the point was xy, it went to yx. So that is about the line y equals x. And the next one we're going to look about is the line y equals negative x, which means xy goes to. You're going to have to flip the points, but because it's a negative x, you're also going to have to change the sign, because the line y equals negative x is the one that goes in this direction. So that was y equals negative x. Up here it was y equals x. So that is how we deal with the coordinate notation. I think on these, some people see them really easily and others don't. So I think these two are probably ones that you need to memorize, so you can remember that when you reflect it across the line y equals x, you flip the two numbers around. And if it's a y equals negative x, you flip the two numbers around and you change their sign. Okay, I'm going to take that graph that's over there and I'm going to translate it. So at 1, it went up 2, and then it went over 2, and then it went up 2 more, and then it ended up at 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. I'm going to connect it. Now what they want me to do is reflect it across the x-axis. So here's the x-axis. One way to do it is to actually count your points and just move your points like we talked about earlier, as far as the x is staying the same and the y is going to the opposite side. Or you can just do it kind of visually. It went up 2 from the red line, so I'm going to go down 2 from the red line. Then it went over 2, and then it went down 2, and then I could connect back right there. And now I've just reflected it across the y-axis. If you would rather, you could take each point. I'm not going to do all of them, but just to quickly show you, the first point was at -1, 0. And it translates over to, wow, it didn't move anywhere. Why didn't it move? Because it's on the line of reflection. So if it's on the line of reflection, the point does not change. If I look at the next set right up here, which was -1, +2, that one changed to -1, -2. So you can see that they're changing as the points go along. That's reflecting about an x-axis. Okay, now this is probably a new concept to you, but it's really one you've already seen in a sense. They want me to reflect it across the line x equals 3. So first of all, I have to remember, what does a line x equals 3 look like? Remember that is x is always 3, y can be whatever we want it to be, so it's this red line right here. They want me to reflect about it. Well, now all I really have to do is think about that being my my y-axis and flipping across that. So when I take my points, this point right here is 2 to the left, so I want to move it 2 to the right. This point is 2 to the right, so I want to move it 2 to the left. And this point is 1 from, so I want to go 1 on the other side. So then when I connect my 3 dots, I've now got that triangle reflected. I think these are easier to do in a visual way than to try to do it with coordinates. So on this particular one, they want me to use the line y equals 1, which means that it's this line right here. So it's just kind of like it's moving it up some. And then they want me to reflect it. Well, this point that's at 2, 1 is still at 2, 1 because it's actually on the line. This point right here was 2 above, so I'm going to go 2 below that line I'm reflecting it across. This one was 1 above, so I'm going to go 1 below, and then I'm going to connect it, and I have now reflected it across a horizontal or a vertical line. So I think of it just like doing it across an axis. Okay, example 2, graph a reflection in y equals x line. The endpoints of the segment FG are f, -1, 2, and g, 1, 2. Reflect the segment in the line y equals x, graph the segment and its image. So you can see I already went through and drew in my y equals x line because I think it helps visually to see it. And then I wrote out my 2 points, and now I'm going to translate them. Remember what my rule says. My rule says for x equals y line, I'm going to take whatever my point is, and I'm going to turn it around. So when I get down here to these points right down here, let me first of all graph my original one. At -1, I'm up 2, so there's point F. And at G, I'm at 1, 2. Okay, so my line segment is FG right here. Now what I want to do is I want to translate my points by turning them around. So F was originally -1, 2. It's going to become 2, -1. And G was originally 1, 2, so G prime is going to become 2, 1. So F prime is at 2, -1. There's my F prime. And then my G prime is at 2, 1, which is right here, G prime. And I connect it. There's my new line segment. So my horizontal line actually turned into a vertical line when I reflected it across y equals x. Some people are great at seeing the reflection. I just find it easier to do the points. Okay, so let's look at another one, only this time we're going to do y equals the -x line. So again, I drew on my line y equals -x going backwards. I plotted my 2 points. So go ahead and do the same thing. Pause the video, plot your 2 points, draw on your y equals x line. Now, once again, we have to remember our rule. Our rule says that we have a point xy, and when we reflect it across y equals -x, we're going to turn it around, and because it said negative, we're going to change the sign on both of them. So it's going to be -y, -x. So my new f prime is going to be -2, +1. My g prime is going to be -2, -1. So again, it's turn it around, flip them around, and change their sign. So f went to -2, 1. So that's f prime. And g prime went to -2, -1. So there's g prime. So there's my reflection across the line y equals -x. So we have a reflection theorem. What our reflection theorem says is a reflection is an isometry. Do you remember what that means? That means if I have a reflection and I have a figure over here and I take and I reflect it across that green line to over here, it will still be the exact same size and exactly the same shape. So it will keep its congruency. So all the angles and all the sides would be the same size when I have a reflection theorem. That concludes our lesson on reflections. All these problems that were left blank on your notes, that's because we're going to go over them together in class so we can make sure you understand it. Have a great evening.